Wait for a few more minutes, or should I start? So I think we should start as per the time. So before I start today's discussion, from the participants, if they have any kind of query or any particular topic they need further clarification, they can also tell us, such that we can discuss that particular thing from any of the previous sessions. And in the meantime, I can also check that few more participants joins the session. So any question from the participants on any topic they need to rediscuss? I think right now, how many participants are there? 14. 12. Shall I start? Or should I wait? Is my screen visible to all of you?
Yes, sir.
Okay, thank you for confirmation. So today, at the very first phase, what we have planned to discuss is that as we were discussing maybe from the very first day of this particular program about a particular topic that we consider to be the backbone of modern deep learning algorithms, that is artificial neural network. And in yesterday's session also, Dr. Banerjee was mentioning about this particular thing, that artificial neural network, about an algorithm which have the capacity to means predict continuous value that we call regression, as well as the give output in terms of some classes, that is called classification. So at the end, the final day of this training session, I think it is very much essential to understand the basic construct and motivation behind this particular what I call the backbone of this modern artificial intelligence, what we are actually seeing in today in the form of like GNAI or any advanced deep learning algorithms. So, but the idea, though this topic is very broad and wide, it is having a lot of depth. It is also having a different dimensions. One is a philosophical dimension, scientific dimension, it's called biological dimension. Also, some mathematical dimensions are also there. So I will try to discuss those things in a very brief way, such that the basic idea behind this thing become clear, and you can have some concept that why we are actually calling this deep learning as a real black box, and why this is being called as deep neural network. Why not a simple artificial neural network? So the answer to all these type of questions will be clarified after I discuss. Then, after the brief overview of this artificial neural network, the session will be handed over to Dr. Banerjee, who will be discussing as per his yesterday's session, that he will be probably discussing with some no-code tools for any kind of real-life problem solving. Okay, so This artificial neural networks is having a term already here that we call neural network. So what is neural network? So neural network means, there are two terms are there, network and neural. Okay. So network means we know that it is a connection, the collection of some interconnected nodes. Okay. So we call here in this particular okay. So at this particular side, you can find this is an example of a network where there are some nodes in blue circles, and there are some connection between these nodes, some directed edges. You can find directed arrows, which are actually representing the connection between nodes. Okay. So nodes basically represent some particular idea or thing or some entity, and edges are the bridges through which each node are connected. So this is the basic definition of network. Obviously, the main purpose of any particular network is to transfer information or data, whatever is from one particular node to another node via some intermediate node if possible. And also each node here have the capability of some kind of processing capability, some kind of what I call processing the previous information it is receiving and then passing it to the next particular node. Okay. Now, when we are calling this to be a neural network, that means this node will be actually representing the simplest form of neurons. So you all know that what do we mean by neurons? Neurons are the basic what I call building block of our nervous system and the fundamental unit we can consider, which is responsible for our what I call information processing, sensing, decision making, and all. Okay, so our brain is actually a collection of this trillions of interconnected neurons, and they are also forming a very complex network that we call our neural network, which is a significant part of our brain. Okay. So artificial neural network is a particular system of interconnected nodes arranged in layers that process input data. So why we have actually felt the necessity of devising this artificial neural network? Because at from the very beginning, I was mentioning one particular thing in intelligent system, or whenever we are trying to develop any kind of intelligent systems, our main focus was to make system as intelligent as human being. Now, whenever our effort is to make a system as intelligent as human being, then the main idea was to find out that what are the specific capabilities which have made human being intelligent. And when it was listed, we found that the top capability, the topmost capability which have made human being to be intelligent is its learning capability. That means human beings are very good at learning from previous experiences, learning from different types of inputs from different sensory organs, and also applying that learning in problem solving, reasoning, decision making in future means what I call in unseen or unknown situations. Okay. So this is the capability. This is one of the capabilities which have made a human being to be intelligent. Okay. So now, whenever we have found that this is the capability which have made human beings intelligent, then the purpose or the effort was to find out how this particular learning capability is what I call developed in human being. And whenever the researcher or scientists tried to find out this answer, they found that it is a very complex network of interconnected neurons, which is actually giving our human brain this type of very complex learning capability. But still, today also, the full functionality of this particular neural network or neural constituents is still not clear to us. But what we have found that the high speed complex neural processing of the data somehow giving us this particular capability. So we have a different part, different types of neurons in different part of our human brain, which are actually functioning in orchestration such that this capability is generated, this capability is achieved. Now, this original capability of neural network that we are having in our brain is very much difficult to bring into any artificial system. So what we tried to do, we have tried to emulate that particular functionality in a very simplified manner. And whenever we found that particular thing, we tried to identify that what are the different distinct part of that particular neuron, what are there, identify it, then model it into an artificial system in a very simplified, I'm again repeating it, in a most simplified way. Then we try to emulate some functionality of information processing that we are having in the brain and modeling it mathematically, and then we are converting that into an algorithm, which we normally call to be an artificial neural network algorithms. So basic function, the main core function of this artificial neural network is slow computing elements to perform complex tasks quickly through distributed computation. So as there are multiple connections are there, so distributed computations are achieved, and the main motivation or inspiration behind this particular thing was inspired that how neurons in our human brain work. So particularly the cerebral cortex, which is mainly responsible for the intelligence and reasoning part in human being. So the why we feel the necessity of this neural network algorithms, only because that the conventional computation algorithms that we already had, we face a lot of limitations in that. Means whenever we are dealing with very complex, uncertain problems, the problems which are very complex in nature, the already I have mentioned in many previous sessions or previous discussions that for those cases where we are not actually sure about what actual algorithm or what actual particular logic is working behind it, or what the particular that example you can always remember, that y equals to fx, where that particular f is unknown to us. So in those areas, actually conventional computation algorithm does not perform well or fails in a simple sentence. So in that type of areas where actually versatile learning is required from different types of data, and basically not only the linear data, also the non-linear data. Okay, so and obviously you know that most of the complex domains or the problems which are actually focusing to solve, like from maybe from biology, from space, from agriculture, from manufacturing. So every cases we are having huge data, but most of them, many of them are linear, but also many of them are non-linear in nature. So when the data is linear, maybe conventional algorithms perform up to a certain level, but if it is a non-linear data, then obviously those conventional computational algorithms will not perform well. And another thing is there that whenever we require algorithmic solutions, okay, so which actually should be adaptive. Adaptive means like when the environment will change, the algorithm will also be capable of learning that change in that particular environment, and based on that it will tune some of its parameter such that it can respond back to that environment in a desired way. Okay. And many cases forecasting, or no, so like sensitive to complex patterns, making them effective in time series forecasting, like stock prices, I can consider temperature forecasting, rainfall prediction, so something this kind of a thing. So these are the areas where conventional algorithm mainly fails, and we feel the necessity of this particular neural network paradigm. So neural network, you can consider right now, up to now, it is a computational algorithm or a particular architecture which is basically motivated from human brain, or rather human nervous system, or like the complex interconnection between the different neurons in our brain, which actually work in orchestration to perform some complex tasks. That means to learn from environment, and based on that particular learning, it reacts, it perform actions back to that environment such that the desired outcome is achieved. Okay. So our main motivation came from our biological neuron. So here in this particular slide, you can see side by side that what is the actual representation of biological neuron, and how we have made this particular idea simplified in a particular simple concept. Okay. So we all know that in biological neuron there are some different components which have some very complex functionalities, and like we have in our neuron, we have dendrites which receives informations from different parts of the body. Then we have a cell body or soma over here, which is actually combine all that particular information receives from dendrites, and based on that it performs some processing, and after that it performs some action. And action means it's a kind of a electrochemical signal, you all know that. And some electrochemical message is passed through this particular action to that next neuron, through the dendrites of another neuron. So this is actually the information processing part in a very simple way. There should be some input areas from where the neuron receives the input. Then there is a cell body or soma which actually collects and combines those input, and after some processing it decides about the electrochemical signal. So that will be passed through the next phase or the next layer of neuron, okay, through this particular action. So this particular thing, whenever the neurons processes the inputs or the signals from different receptors, it performs some kind of chemical or electrochemical operations here to take action, to decide, to identify, to recognize about the different types of signals it is receiving from its dendrites. Okay. Now, whenever we are talking about an artificial neuron, the case we have made very simple. Okay. But the common things or the main components are kept intact. Like as we hear dendrites, we had to receive the information from the outside environment. Here also we have some input channels or input nodes you can consider in an input layer. Okay, so which will be these, but nodes will symbolize one of these dendrite channels or inputs, which will actually take the input from the environment. So here, whenever we are talking about the environment, we are talking about the data that we have received from the environment. Okay, so data, when we are talking about this x0, x1, x2, x3, these nodes are nothing but the input path of the data that we are going to, what I call, that we are going to learn from. Okay, so the data which we will use to learn. So this will be given through this particular input layer. Okay, now here also we had a cell body, if you can find. Here also we have a node here. And like in biological neuron, as I've said, that all information received through these particular dendrites are collected over here and processed. Okay, so this is a very complex electrochemical biological process, but here the process is very simple, not that much complex. Okay, after receiving the inputs, here are some other informations. We can consider other metrics are also there that we call normally the weight or component or a parameter, which is actually multiplied with the input, actually input that is received through this particular node. And after that, it goes to that particular cell body or a area where this all the information along with their weights will be processed. How this will be processed, I'm coming to that particular thing. but try to compare that how the things are similar and where the things are different. Okay, so here we have some weights. These weights are initially randomly assigned, but as the learning process will proceed through different iterations, these weights will be automatically adjusted, and these weights are the most important parameter of the component in learning. Okay, isn't it? So it also happens in our case also. Whenever we see different types of colors, if I'm talking about, so each and every color like generates a different type of sensory response in our brain. Whenever we find whenever we see any red light, red color or yellow color or blue color, all the colors are actually what I call uh, creates a different type of sensory experience in our brain. Okay, so how these things happen? Because every colors, it is nothing but some spectrum of light which is actually received through our eyes and again passed through a same sensory pathways or electrochemical pathways and received to our brain, where these things are decided. But basically each and every color creates a different weights in a very brief sense, though the weight is not biological term here, but a different weight, a different sensory experience, okay, through which actually we can signify or differentiate between different types of colors. So initially here also, whenever we will be giving some inputs, these inputs are again multiplied with some weights. These weights are actually adjusted and readjusted in different iterations in my learning phase, and that I will come to this particular thing later. So this particular cell body does what? Collects all these inputs, multiplies weights to each of the input, then sum them up. Okay. So this is the main one of the main function here that we perform. So collect all the inputs from my input channel or my input nodes, multiply each input with the weight, and then sum it up. So here it will be x0 w0 that will be coming and reaching over here, x0 into w0. Here this particular input channel will come here as x1 w1. It will go here as x2 w2 like this, and finally okay. So here this part will be, as you know, that these two will be multiplied. So like it will be x0 like w0, then the same way x1 w1, x2 w2, then xn wn, all will be summarized over here. So this is the first uh, operation that is performed over here. And secondly, another important operation that is performed here in this particular area that we call where the processing part takes place, that is activation function. So after summing all this particular input, that particular summation is passed to a function, special function that we call to be an activation function. I will make the purpose, I will just make the idea clear that why this particular activation function is basically used. But the very simple idea, the simple concept, I will say that whenever we just sum all these particular inputs, it gives you a linear representation, because you know w0 w1 sorry x0 w0 x1 w1 plus x2 w2, if we plot in a particular two-dimensional axis, x-axis y-axis, if we plot two-dimensional space, it will basically represent a line or a linear representation. But actually the nature of the problem is basically non-linear in nature. So whenever we are collecting all the inputs from all the channels and ultimately making it a linear representation, that means many of the important properties which are actually there in the form of non-linear pattern are lost. So that is why the actual exact pattern in that particular data cannot be accurately represented in linear form. So there is a requirement again that we need to convert this linear configuration to a non-linear like representation. And to do that particular thing, we use this activation function. So I will come to that later. So basically, the biological neuron and artificial neuron are similar in cases like it is also having an input channels. Both of them have a processing area and also an output channel. So in this way, it is very similar. Like dendrites to cell body to action, here also input to the hidden layers to the output and processing. But here, what is not present over here is that our biological neuron is having the capability of massive parallelism. Okay, though the slow processing unit in milliseconds, but it is having a massive parallelism. But here, in this particular artificial neuron, the fast processing between each channels. Okay, so never find that our biological neuron is slow processing. Slow processing speed means in the form of transferring information from one node to the another particular node. But if I consider the overall processing and complexity, then it is also very fast in that particular case. And in particular learning capability, if I are talking about, obviously this complex the biological neural network having a neural connectivity that changes over time, okay, and adapts based on experience. But normal cases, in normal situation, artificial neural networks have some fixed mathematical weights adjusted during training, okay, but weights remain static during testing. So once the training has been achieved, the weights remain fixed, and after that, until and unless we retrain it, the weight does not change again in future. So the simplest form of artificial neural network, we call them to be a simple perceptron concept. So which is the simplest form of neural network unit, also known as a threshold logic unit, TLU, that you know. So this is a very basic and fundamental thing from which the rest of the complex parts evolved and came. Okay, so it is having some distinct components. One is the input that I have already said. Okay, now if you can find here, other than input, here is again a specific node which is labeled as bias. Okay, so this is a special type of node which is actually different and independent from the input, which is having a fixed value. This bias is functions like a intercept in our y equals to mx plus c, the equation of a line, you know, it is y equals to mx plus c. So the function, what is the importance of that particular c in any linear equation? Can anyone tell? So if my suppose equation is y equals to mx plus c, so what is the purpose of this, or what is the like what is the significance or importance of this c over here? Anyone? In any particular linear equation, a line. What if the c is not present in any equation of any line?
C is the intercept.
So if c is not present, then what will happen?
It will start from origin.
Yes, it will always pass through the origin. Very good. So here, this bias, this b, also the function, mathematically it behaves like this intercept. So like as I was saying, that if you check this equation below over here, that whenever all the inputs are collected, they are actually combined in this form: w1x1 plus w2x2 plus wn plus b. This b is actually known as the bias that I was talking about. Now this bias, if I consider this is the mx part, this w1x1 plus w2x2 plus w3x3, like this, these are this mx part, and this b is actually the c part. So this will represent actually this w1x1, w2x2, x1, x2, x3 are all actually means representing the feature space. isn't it? So if we do not give the bias, I am telling in two different there is no sorry equation of a particular line and linear equation. There is no doubt about that. It is having two part. One is this mx part and this is the c part. So this part is actually representing you the mx part, and this plus b is actually the intercept part, this c part. Okay. So if this b is not present, as you have correctly mentioned, then all this particular line always will pass through the origin of the feature space, which is very impractical in real life situation. Okay, so this is very much required here to make it distributed over the full feature space, number one. Now biologically, or actually if I look it from a practical point of view, this bias actually makes this whole network means not fully depend only on the input. So you can easily understand that if at any particular situation, if none of this input is present, then this neuron will not fire. Fire means this neuron will not pass any information to the next layer, which is also very much impractical in some situation. Maybe in any particular iteration, this may happen. But this bias actually keeps it active somehow. So if any part of this particular mx part becomes 0, this b part will be there. So this bias part will make it active at least. This is one thing. Another thing is there. So normally biologically there is again a significance we can consider that our sensory inputs that we received from different sense organs also receives different types of signals, pulses that we call. Okay, now all pulses does not actually generate any signal, does not generate any kind of impulse which is required to be forwarded to the next part of the network, that is the neural network. Okay. So this bias is kind of a push you can consider, which if actually the sum of this particular W1 X1, W2 X2, W3 X3, this particular part, okay, this add some extra value or extra weight to this particular equation and make it pass to that particular neuron such that it fires. So something like that. Okay. So this B part is the intercept part mathematically, and this is the MX part, such that it gives you a linear look. Okay, they look like a linear function. This is the part, and this bias is an extra push you can consider to make the neuron fire and pass the information to the next layer. Okay. Now there is another part that we call, and also this particular bias having another importance, that it makes the activation function to feed data in a better way. Such that it does not always go through the origin of the whole feature space. This activation function you can just from, if you see the Z function, it is a linear function. Okay, so it cannot represent any kind of non-linear pattern that is hidden in that particular data. This activation function makes this linear when maps that particular linear data to a non-linear space once again. So if I consider, so this is a simple perceptron architecture. Now we can make this architecture more complex to learn more complex pattern in that particular data by adding layer to this particular thing. Now the simplest thing that we call as a single layer feed forward network. Single layer means there will be only one input layer, one output layer. Basically, as you all know that feed forward means information will be always passed towards the forward direction. So it will be proceeding towards the forward direction. So here, if you are consideration of the case, either from the left to right or from the right to left, from the input towards the output. So if I represent the input layer to us in the left side, so the flow of the data will be from the left to the right. So this has to be always true. So whenever the data is always passes from the input layer to the output layer in a singular direction, in a forward direction, we call that particular network to be a feed forward network. So it consists of a single layer of weights where inputs are directly connected to the output. This is the main mechanism. And you all know that this is the always the function y equals to f of x. So this particular x will be taken care by this particular network. Okay. So sum of the products of the weights and inputs is calculated, and if the value is greater than a particular threshold, then the neural will fire. Otherwise, it will not fire. It will remain deactivated. So this is the main mechanism. So all the inputs will be considered and will be added, multiplied with the weight, like as I was showing over there, that x0 w0 plus x1 w1 plus x2 w2, like this. So all the product of weights and input is calculated. Then there is a threshold value. We just check whether the sum is greater than particular threshold. If it is, then the neuron fires. If it is not, then it remains deactivated. So this is the simple mechanism of that particular network. And basically, continuing like this, it gives the output. Okay, and based on the output, again we check how different it is from the actual output or the desired output, and that we call the residue or the error. And based on that particular error, weights are adjusted to minimize that particular error whenever output does not match the target. So this process continue till the error is actually minimized to a certain level. But this particular single layer feed forward neural network have a limitation that it normally cannot segregate, because here we didn't apply any kind of activation function you can find over here. So it does not represent, it is not capable of solve the problems which are actually not linear in nature. So if we have the data set which are linearly separable, this particular algorithm will work fine. But if they are not linearly separable, this will not work at all. So those who are from technical background, they easily know that if we just plot the data set logic gates, like we know the different logic functions like AND, OR, and XOR. So all this AND, OR are the plots if you can find. So if you know that the truth table of AND, so this is, it is actually one only when both the inputs are one. So if I represent this particular field blue circle, this is to be the one, and other input combination gives the result as 0. So one can be represented over here and other three are here. So this I can easily segregate between this field blue circle and this other three circles through a single line. That means this particular problem can be, the output can be linearly separated. Same here for the like OR also. But XOR, we cannot draw a single line to segregate between this field blue circles and the normal other two circles. So single line cannot separate these two types of outputs or two types of data. So that is why this particular typical thing makes this XOR problem as a non-linearly separable, which is not linearly separable. And if we just plot our data set from most of the real life complex problems, they are not linearly separable in nature. So that's why we need to increase the complexity of the network to address those problems. And for this particular purpose, we feel the necessity of multi-layer perceptron. Okay, so earlier we found that it was a single layer, but single layer has not the does not have the capability to deal with the non-linearly separable problems. So that's why we need to increase the complexity. And whenever we are increasing the complexity and adding multiple layers in it, slowly it will generate the capability of dealing with the data set which are non-linear in nature with the special inclusion of a special function that we call the activation function. So this particular diagram represents a two layer normally. Multi-layer means more than one layer. Whenever it is, we will call that to be a multi-layer perceptron. Now you can find here, other than the input layer and the output layer, it is also having a hidden layer, and each hidden layer is having a activation function. Okay, rest of the mechanism is same. All these nodes from the in the hidden layer receives inputs from its previous layer. Okay, all inputs are weighted inputs. So if I in this input layer I am having this I1, I2, I3, these are the inputs, and each of them are having their own weights. Okay, now whenever this particular information will be receiving to this particular hidden layer neuron 1, that is called the H1. So you can find that H1 is receiving input from I1, from I2, from I3 as well. So it is obviously this I1 will be multiplied with this W111, then it will be W112, then a I2 W112, then I3 W113. So in this way, all the weights and inputs will be multiplied and will be reaching to this hidden layer, the neuron of each neuron of this hidden layer. And after that, the same sum operation will be there. But after that, it will be passed through a activation function. Then it will pass to the next layer or the output layer. So here adding hidden layers enable the feed forward neural network to represent any function. So this hidden layer is actually giving this network the capability of what we call as a function approximator, or this particular hidden layer and this particular mechanism is so powerful that it can capture the, rather it can approximate almost any kind of functions, like almost any kind of pattern that may be present in the particular data. So that is why this particular architecture sometimes called as a universal function approximator. And obviously there should be a error correcting mechanism that I will come to that later. So that is why it is called a universal approximation theorem, that a network with hidden layers can estimate complex and non-linear function. Okay, so it can also distinguish data that is not linearly separable. So earlier we have the capability of separating data, distinguishing data which were only linearly separable, but this particular network has the capability of separating both linear and non-linear. But here the major problem is that as much as we will increase the number of layers, complexity will also increase. And when the complexity will increase, more number of layers means more number of parameters. That means more training time, more resources. Okay, so that will be required. Now you can consider, you can think over here that only this one input layer and one hidden layer and one output layer, we can find so many parameters. Like here, if I these are the inputs. Now this particular weight is a parameter. So each particular neuron in the hidden layer receiving 3 different parameters here. And if we have another layer here, so that particular layer will also receive these many of parameters. So one thing is very much clear, that as I will make the number of layers, I will increase the number of layers, the number of parameter will also increase. And at the same time, if I increase the number of input nodes, also the number of parameters will increase. So this is a very simple, or the most simplest form of neural network, with one input layer, one hidden layer and one output layer. But in actual practical situation, when we are actually dealing with real life problems like weather forecasting, stock market prediction, image analysis, or whatever it is, our architecture is very, very complex. So they that those means architecture have means hundreds of layers. Okay, and maybe more than hundreds of parameters as well. The one of the simplest real life problems. So there you can easily understand the number of parameters. Okay, So I think all of you have heard about, so those who are familiar with this deep learning and GNAI models, they might have heard about that a model is 3 billion parameter model, 1 trillion parameter model, 2 billion parameter model. So this type of each and every model have their own number is attached with them, that how many number of parameters are already trained to train that particular model. These parameters, you can billion and trillion parameters are there. So do you think that if if we take a pen and paper or a simple Excel sheet and try to keep track of all these billions and trillion parameters, how their values are changing in each iterations, how their values are fluctuating, either decreasing or increasing or interrelated with each other in which particular way, through any pen and paper or through Excel sheet or through some documented way, it is almost near to impossible. That means it is almost intractable in nature. So up to a certain level, one or two layer, we can have some kind of idea about the visibility or the working or tractability of all these parameters. But as my number of layer will increase, the overall tractability will be lost. That means we will have no idea what is happening with this particular W's or other parameters, weights or other parameters. So we can understand that what is happening, these weights are there, they are adjusting themselves based on the error, but in which particular way, what are the, how their values are changing with each, with the intervention of any all other parameters. So these become almost intractable as the complexity of this particular network. So whenever the things will become intractable, it becomes almost invisible to us, isn't it? So as we all know that whenever, 1 minute, as we all know that whenever if I talk about a deep well, so if the well is shallow in nature, we can see the end of it, isn't it? Light can reach there, we can see the end of it. Okay, that is the end of the well. But if the well is too deep, what will happen? After a certain level, after a certain height, we everything becomes dark. We know there is an end, but we cannot see its end. And what is there beyond it, either it may be a like hole or it may be a well, we are not able to see the end, we are not able to check what is happening out there. So it becomes deep. So our concept about deep is there, after which we cannot see or we cannot visualize. So here that particular architecture is will be called as deep, in my opinion, that because after a certain level we cannot visualize what is happening inside, we cannot visualize, we cannot track the calculations, how they are changing themselves. Okay, so that is why this architecture becomes deep, and we call them to be a deep neural network. Okay, and as we all know, everything becomes dark, we have no option, no control, and no visibility, no tractability about those particular weights, what is happening inside. We call that particular architecture to be a simple black box architecture, because we have no control over how the things are changing in each iterations or accordingly. So this is the basic idea behind this deep neural network, and why it is basically called deep, and how why it is basically called the black box kind of a thing. So ordinary feed forward neural network works in a very simple way, as I have mentioned, that input, the information is taken in the input layer, then passed to the hidden layer, and then forwarded to the output layer. So there is no feedback or recurrent path. So that is why it is only called a feed forward neural network. Okay. But another type of neural network is there, which we call the recurrent neural network. I will not go into the details of that, where which is actually having the feedback connection as well. This feedback connection actually enables that particular network to keep a memory kind of a thing, which actually enables it to remember the previous information, or the information to the previous input or the previous data it has already processed. So if I talk about a full FNN architecture, it will be a fully connected network. So here the two different types of networks are there. You can consider here if there are four input nodes over here, x1, x2, x3, and another layer is having suppose hidden layer a1, a2, a3, a4. So there may be how many different types of connections can be possible. From here, each a1 it can receive four inputs, these also four inputs, these also four inputs. So if in any particular network most of the possible connections are already there, okay, if nearly all connections, all possible connections are already there, then we normally call that particular network as a fully connected or dense neural network. But if some of this or most of the connections or many of those connections are absent, to provide some simplicity in that particular network, simplicity of what I call reducing for the purpose of reduction or reducing the training time and other related complexity. So some connections may be off, or maybe all possible connections may not be there, but still the information processing is achieved. Still the learning purpose is achieved. Then we call that particular network to be a sparse network, where some of the connections are not present. So dense means all possible types of connections are available, and sparse means very few of them are present. The majority of them are not present. But in both the cases, we have to check that the purpose is kept intact, that the architecture keeps learning from the data, training data based on the algorithm that is it is provided with. So again, the same thing that I am trying to focusing over here, that it is having a different representation. So input is generally represented in the form of matrix, okay, and as you all know, and there is a simple linear step where we combine all the inputs x1 w1 x2 w2, and after that the bias is added. So this is a linear step, and after that it is passed through a activation function, which is generally a nonlinear step, okay, and layer wise computations are also there. So this is the sample connection means calculation for a single node in a single layer. So in this way, this will be calculated for each and every node for all the layers accordingly. So here you can easily understand that here a lot of mathematics are required. This like what I call linear algebra or related mathematics are required to understand this matrix representation of the input data, and keeping track of the weights that are present over the different edges of the network and their calculations. We require uh, like what I call the set of activation functions, and different type of there are many different types of activations functions for different purposes, have each and every of them having their own strength and pros and cons and their own purposes. So we have to select and identify those activation function very wisely whenever we will be dealing with any particular problem. Okay, there are also some like other type of mathematics is required, that I will come to that particular part later. I will just name them. Okay, so this is the simple numeric example, the things, how the things happens basically in forward pass. I will request all the participants to have a look if you are not, the idea is still not clear, but if it is clear, if it is not clear, you can ask me anytime. Any particular thing is very simple. There is a mathematical representation of that particular equation that I was showing in the previous slide, and those are actually how those are combined. And this ReLU is one of the activation function that I was mentioning about. It is having some special characteristic that I will show you later. That is, one thing is always remember that each and every neural network have their own input matrix, input representation, their own weights, bias, and activation function. These four things are very much clear and common to every type of this multi-layered perceptron network. You have to always remember, other than the network setup. So some one input layer will be there, some number of hidden layers will be there, and one output layer will be there. and the purpose will be to learn. Learning meaning what? Learning means to reduce the error. So one thing is very much clear. I will give the input. Those input will be processed in the hidden layer and will be passed to that output layer. Okay, an output layer will be giving you the predicted output, and we will find the difference between that actual output and the predicted output, and with the help of a loss function. Here it is represented in the form of L. So this loss function, okay, will calculate the error, and then this error will be back propagated to the those hidden layers again for the purpose of readjustment of the weights and bias, such that in the next iteration the error is reduced. So here the thing is there, earlier we were discussing about up to that information will be passed forward only, but here again we are adding one another important paradigm that we call error back propagation. So for information is passed forward, but the error is propagated backward. For what? Because error is coming due to what? Due to the selection of this weight parameter and the bias parameter. So if we need to reduce the error, obviously one thing is very much required, readjust the weight and the bias. But how these weights and bias are related to this particular loss function, that is actually we have to mathematically represent, because you all know that loss function is the result of this weight and bias. So a slight change in the W or B, there is weight in the bias, will also will be reflect in the loss function at the end. Okay, so this, how this particular loss will be changing based on the slight improvement in the weight and the bias, this mechanism we have to calculate, and this particular calculation is achieved through differential calculus. That is a different part. I will not go into it particularly, and this particular thing, but one idea should be very much clear, that here the two different paradigm works. One is the forward propagation, where the inputs are taken from that input layer, passed to the hidden layer, then the output is produced, and once the output is produced, the loss function measures the error or the loss between the predicted output and the actual output, and that particular loss or error is again passed back to the previous layers for its possible readjustment of weight and the bias. So this particular phenomenon is known as backward propagation. So forward propagation and backward propagation both are present in this type of network. So that is why this network is called namely feed forward neural network with back propagation of error, simply. So this is the particular purpose, how the basic neural network works. And these things I will not discuss. This is actually will be showing that how the loss function will readjust the weight based on the simple differential calculus, So that's why this particular artificial neural network involves different types of mathematics. One is the linear algebra to represent the input matrix, weight matrix, and all. It require also the probabilities, statistical probabilities, different functions like activation functions or all. It also required calculus, the back propagation of error with the calculation of autogradient that we call. So different mathematical components are there. So these components are to be calculated each and every iteration of when it is being trained, when the neural network is being trained. So if you can remember, I was telling about in the previous session about frameworks. So right now or nowadays, earlier the coders or the researcher had to code each and every step minutely and separately. But nowadays, with the advancement of different or with the availability of different framework, we do not have to bother about this different mathematics. We have to call the function, and this framework will take care of all these particular different components that are involved in this particular neural network. We only have to make it clear that how many hidden layer we are asking, because input layer number of neurons in the input layer will be automatically decided based on the input data you are providing. You have to only decide about the how many hidden layer will be there, how many neurons in each hidden layer will be there, what type of activation function you are going to use. Okay, so and how many iterations you are actually means willing to have before you means terminate your training algorithm, or you can also specify some specific criteria or threshold based on which your like training iteration or epochs that you normally call will continue. Okay, so basically calculate the output error, then propagate that particular error to the hidden layer. This is the main purpose of this backpropagation functionality. And based on that particular error that is received, the weights had to be readjusted, okay, such that in the next iteration the error is minimized. So the full detailed working and functionality of backpropagation algorithm, I think it is not in the scope of this particular discussion, so I am skipping this particular mathematical part right now. The very simple introduction about this activation function I am telling you. So these activations are some special type of function which has the capability of making any kind of linear function to non-linear in nature. So this is a very popular activation function that is known as sigmoid, you know. So whenever sigmoid takes any particular function y, that you call, here it is represented in the form of z, so it just converts this particular like input z in the form of 1 by 1 plus e to the power minus z. So this is such a kind of representation. Whatever may be the value of z, if you just plot it in the sigmoid function, it will always range between the 0 and 1 in this particular way. Okay, so as the value will be less than the 0, it will reduce in this way, and as we more proceed from more than 0, greater than 0, so it will proceed in this way. It will always will be capped between 0 and 1. So this is the specialty. Any type of input you give as z, but it will make it capped between 0 and 1 in this particular non-linear nature. Okay, so this is actually used, very popular sigmoid activation function, which is used in mainly classification problem in the output layer of the classification problem in many cases. And here tan h is another function where the threshold or the where again we give this particular input, but here the purpose that we have to keep the output between -1 to +1. Okay, another function is there, that is ReLU, which is mainly used in convolutional neural network. If I have found that there, here the main purpose will be whatever may be the input, it will make it all the values which are less than 0, sorry, which is less than 0 to here in this particular level, 0 level, and other than it will be accordingly as you can find in the graph. So it will having a positive value. So here we will not get any negative value of this particular thing, of this particular output. So that is why it is a function is being represented as a maximum of 0 or z. So it is, if it is greater than 0, so it will give the z as output, but if the value of z is less than 0, it will give output as 0. So this is again a activation function. So these are the some special type of activation functions which are actually used or applied in the hidden layer or the output layer of the neural network, just to make the linear input to a non-linear output. Okay, and also I can see this is not the only reason. There are many other reasons are also that is not under the scope of this particular discussion. But one thing is, I can say that this activation function makes the output of the calculation more like what I call suitable for this complex network calculation, more digestible by the network, I can say in a simple term. Okay, so this is the basic architecture of artificial neural network that I have already said, though it is a very vast and broad topic, but in a very brief way I have tried to explain this, because whenever you will be thinking about deep learning, multi-layer perceptron, convolutional neural network, recurrent neural network, whenever you will be listening to this particular term, you are sure that some neural network is over there. And whenever you will be learning about this or hearing about this term neural network, you will be sure that there will be some kind of some layers of neurons, and one of them will be the input layer, one of them will be the output layer, and based on the complexity of the problem or the algorithm, you will be having a number of hidden layers. So this input layer, output layer, and hidden layer. These are the three distinct component of this particular like neural network. And again, you will be having some weight metrics. You'll be having some like activation functions. So these are the terms related to this particular neural network. So if you check any particular code of any deep neural network learning algorithms, you will be finding these components already there intact. So this architecture at a very simple glance may look very simple if we just means exclude the detailed mathematics behind it, but it is a very like I can say that very effective architecture and network which has become very fruitful in understanding or realizing any kind of complex data set, or rather understanding or approximating any kind of complex function. It may be text data, it may be image data, it may be like audio data, or it may be any kind of thing. Whatever it is, it can approximate very well. So that is why it is known as basically universal approximator. Okay, and this algorithm is mainly known as universal approximation theorem. And other version, it is not always multi-layer perceptron. So multi-layer perceptron is one of the what I consider one of the application of this neural network architecture. So other than that, we have for image processing, we have convolutional neural network, which is having some other extra steps before this multi-layer perceptron come into function. And we also have recurrent neural network, which is very good in sequential data processing like speech, text, something like that. Okay, so that is also having this neural network concept, but with having some feedback loop and some memory, which actually remembers the previous sequence what is already received. So these are the very common neural networks like which are popularly used in most of the deep neural network architectures or applications, but having some enhancement, some kind of modification, some kind of improvements. The names are different, but basic thing is this what I have basically discussed. So now I would like to, without means making any kind of further delay, I would like to ask from the audience that if you have any kind of doubt or if you require any kind of clarification regarding this, I will try to answer. Any question? Any question from the audience?
Whenever
In
we
your
use,
opinion?
when the analytics teams, when they talk to business,
Hmm.
uh, and when there is a suggestion for a model, they tend to use some simpler machine learning models or other statistical models, but do not suggest ANN,
Hmm.
because in some legal cases or wherever sensitivity is involved, they say we cannot explain the model, so we don't use ANN.
Hmm.
Though the results may be better with ANN. Why is this so? You were able to explain so much
See,
on what is
see,
happening in the
no,
model.
no. It is not always that it is artificial neural network means it will function always well. No, it's not that. Already we are mentioning from our few of our previous sessions, Dr. Banerjee also have explained that we will use, this is one of the option, okay, but this option is having the capability of very good function approximation, but it is also having some constraints. Constant means if your data set is not large enough, if you do not provide sufficient amount of data, okay, it learning may not be fruitful, or it learning will not converge. Okay, means it will not learn in a proper way. Okay, so if it does not learn in a proper way, it may suffer due to two different problems. One is overfitting and the underfitting. Okay, so if these things happens, then your algorithm or your purpose will not be solved. But whenever people are saying that normal, simple machine learning or statistical learning algorithms are working fine, then why not go for them? Because my purpose is to either classification or regression and reduction of error as much as possible. So if I can find that my normal simple algorithms like logistic regression, support vector machine, decision tree, random forest, which are using exponentially less amount of resources than artificial neural network for training, then why should we not go for that? Because if my purpose is solved, then obviously I will not opt for any complex algorithm which may suffer due to the non-availability of proper dataset, isn't it?
Yes, makes
And
sense.
always remember the one thing that neural networks or deep neural network things means sounds very good, isn't it? Very efficient and effective. But whenever I'm talking about resources, it is very huge number of resources are required. So when I am talking about suppose 1 billion parameter model in architecture, that means remember there are 1 billion parameters which are trainable. We have to train those 1 billion parameters. So can you imagine that how much kind amount of resources will be required to train that particular 1 billion parameters? Here in this diagram, simplest diagram, we are finding that there are almost about how many 20 to 30 parameters are present over here. Now 1 billion parameters. So obviously, if the necessity is not arise, we will not go for that complex problems. Okay, but if machine learning algorithm fails, if we do not have any idea, if my data set or my is very much unstructured, uncertain, we have huge data set, but we have no clue about what is happening inside. So those are the areas which are suitable for this particular deep neural network architecture.
Thank you so much.
Any other question? Any other question from the audience? Any other comments? Any other discussion? So as this is the final day, anyone willing to say something? Okay. So as this is the final day of this particular training program that we are talking about, so I would like to say one thing. Always identify, analyze the problem that has come to your hand, okay, that you are required to solve. But give more time on understanding the problem. Then try to find out the type of algorithm you are requiring, whether classification or regression or something else. Okay. Then try to understand the complexity. Visualize the data. If it is too much like what I call sparse or distributed or noisy, okay, then do not go for the normal machine learning or statistical algorithm. But if you feel the data are very structured and straightforward, but it is very like complex in nature, or a lot of different parameters are there, you are not directly find any kind of insight. Okay, so then machine learning and deep learning can be a very good example. And one thing is very much clear, that whenever we are in the era of Gen AI, like LLMs, ChatGPT or something like that, so this type of huge amount of training and huge amount of reasoning functionality will not be achieved or could not be achieved with the help of those simple machine learning or deep learning. But if I have to predict the sell, or if I have to predict the price, so in those type of cases, a simple machine learning and statistical algorithm may be fruitful. But whenever we are talking about image recognition, object recognition, okay, we are receiving huge amount of data from the space or from geological survey, or we are getting some unstructured data from any particular biological experiment and all. Okay, so in those type of cases, obviously you have to think about this deep neural network. Okay, so I have received one question. the chair, that what should be used for air pollution data analysis. Okay. So again, here we have to check that what type of data I am having. Air pollution data analysis means, obviously, if I check about the some pollution constituents, like what do you call carbon monoxide, sulfur dioxide, PM 2.5, PM 10. If these type of data are there, okay, yes, PM 2.5, PM 10, or RA, something like that, and air temperature, as you are correctly mentioning. Now the thing is that what you are going to achieve after analysis. So analysis simply means we can do some kind of exploratory data analysis or visualization, get an idea. But when I am talking about, like, I would like to predict that what will be a PM 2.5 level tomorrow or day after tomorrow in that particular cases. Then my decision making comes into consideration. Yes, I was telling that you would like to do some forecasting. Okay, so in that particular cases, see, though now it has become a very popular and well-known research. So if you search in the literature, you will be finding that a lot of literatures are there where different, like hundreds of algorithms are applied for this particular forecasting. Many of them have used like normal machine learning algorithm with support vector machine or decision tree. Few of them have used some other regression model, like auto regression model, that are from simple like statistics. But if still the results are not satisfactory, or if I would like to make something long term prediction, because prediction are different types, short term and long term predictions. So, and if after a certain level your accuracy does not increase, then obviously we have to think something different. Different means thinking something different or trying something different does not always mean that you will get a better result. Suppose by applying simple machine learning or statistical algorithm, you are getting an accuracy up to 75% or 80%. Okay, you are not satisfied with that. So then obviously you have to try deep learning algorithms for if you can further improve the accuracy of this forecasting or prediction. But always remember, with the same data with your hand, which you have applied for this support vector machine or random forest or decision tree from normal machine learning, then these things are not going to work, because data set, I'm always telling you, if you like to apply a very complex or deep neural network architecture, your data should also be of very high or large volume, because until and unless you give sufficient amount of data to that particular network, these W's are not going to be adjusted accordingly such that it can identify the hidden pattern that are present in the data. But it is having a huge strength as well, which are the things or the pattern which are almost not visible by the statistical or this normal machine learning model. It can also find out the very minute pattern which are hidden in there. But for that particular purpose, you need to give a very high volume data set. Then only this particular architecture will give you, or there is a chance that it will give you a better result. But but one another thing, that if you have a very large volume of data set, still, and your architecture is fine, your pipeline is fine, but still you are not getting a good accuracy as an outcome, then remember that your data set is not relevant. Meaning what? That Dr. Banerjee was one day was saying, that if you can remember, dependent and independent variable in y equals to fx. Okay, so these x are the independent variables and y is the dependent variable. So y is the dependent variable, so depends on whom? Y depends on the x. But if your x or feature set are not related to y, you may have a very high volume data, but if it is not related to your outcome or your purpose, then that data set is not going to work, isn't it? So you should also have a very large volume data set, but at the same time it has to be very much relevant data set. Any other question? Yes, you have done basic analysis to fix the DV and IDV. DV and IDV means you are talking about dependent variable and independent variable. If it is, then it's okay. Obviously, some basic analysis obviously you have to do. You can apply that. One of the popular way of doing this is correlation matrix. You can generate that a check what is happening out there. Okay, but things actually sounds very good. These are the things, but actually whenever you are in the actual dealing with the real life societal problems now, which are very unknown or complex in nature, these common things will not work. You have to explore different things, different ideas, different logic. You have to experiment with the things, because at the very first time, whenever you will be directly dealing with industry problems, at the very beginning you will have no idea that what are those dependent variables. You know what is the outcome, but you have to also understand that what are the dependent variables, and for that particular purpose you need some domain knowledge. You need to do some kind of literature survey, some kind of survey analysis, and all the things to identify that dependent variable. And once you have identified, then you have to search for the historical data, that which data we are having from which particular resource I have to collect that. So all of the things are there. Okay. Any more question? But there is a lot of different scopes in the domain of biology. I'm taking what I am finding is that biology is going to have the overall biology and chemistry, biochemical industries, and all is going to means have a wide range of application of this AI, deep learning, machine learning. A lot of things are there which is going to be found out. And for this particular purpose, now the researchers are finding these tools are very fruitful. So those who are interested in biological domain or biochemical domain, specifically this molecular microbiology or something, so there also a wide range of applications and innovative areas are also there where people can apply this different AI algorithms, deep learning algorithms for finding good insight or result. Okay, so if you do not have any question from this particular session, so I would like to hand over the session to Dr. Banerjee, probably for some practical demonstration. Okay, so in between, if you have any questions or queries, you can always ask. Probably you are having our email IDs as well. So you can always send us an email for any kind of queries and questions. No problem with that. We are always there to discuss with you, because we also will be learning from you in future. We are quite sure about it. So thank you very much. So I will be now handing over the session to Dr. Banerjee, if you are here. Dr. Banerjee, are you there?
Yeah, I'm here. Just went for a coffee.
Okay.
Okay. Uh, I was here for the session and I heard what Dr. Thakur had said. Am I audible?
Yes,
Yes,
yes.
sir, you're audible.
Okay. Question is irrelevant because if I'm not, then how would you answer? But still, I'll just share my screen. So today's session, I'll not be going into any sort of coding. Okay, is the screen visible now? Okay.
It is visible, sir, but can you just zoom it up a little? We're not able to see it.
Oh, wait up. Is it visible now?
Yes.
Yes,
Okay.
yes.
The thing is, Dr. Thakur had been talking about ANN, neural network. So I will not go into the depths of it. So there's too much thing into it. Build up. It builds into DL, deep learning and all. I'll start by answering Mr. Mulli's question regarding why not ANN. I was hearing that. Uh, the thing is, as Dr. Thakur has aptly said, it is costly to train. R&D people will refrain from doing so because it costs a lot. The infrastructure and the logistical ones is huge. Apart from that, as Dr. Thakur had already said, that why would you need it when you need actual solutions rather than the suboptimal solutions? ANN is required where the F is not known. If it is known, use a normal ML model or some other models, uh, algo, statistics and all. But if it is not known, ANN is a way to go. But in certain cases like sales forecasting and all, seldom do we need artificial neural nets because a normal statistical model will actually answer that pretty well, and it will be mostly accurate. Artificial neural networks, DLLs, DNNs are actually not required. Apart from that, ANN has got a very big flaw, as Mr. Murli was saying, that it is not explainable. It's like a black box. You put in input data, you get some output. You do not know what goes inside. That statement is almost like a myth. Your R&D team, your IT team is evading the cost. More or less, ANNs are explainable right now. If it is designed by a human properly, it can be explainable to certain extent, and which is good enough. So maybe your R&D and IT teams are evading the cost. I'll go deep into this right now. As Dr. Thakur had already said, that we need an input layer. Then we need 3 or 4 or other neurons in the hidden layer. And then we have the output layer. So first one is my input layer. Second is my hidden layer. And the third is my output layer. This second one may be many number of neurons with many number of hidden layers. Currently, we have 2 nodes in the input layer and 3 nodes in the 3 neurons in the your hidden layer, and there is only one hidden layer, and there are 2 neurons in the output layer. Why? Because we are doing a binary classification. Binary classification says either 0 or 1, so we have got 2 independent nodes for this. Had it been a regression model, how many nodes do I need? A regression model provides a prediction of one single variable in the future. So if there is one single variable in the future, I would be requiring only one node. Let me just drop it down to regression, and you will immediately see that one of them has got no connections active. If I go back to this classification, you will see now both the nodes are active because we are talking about here currently as a binary classification. Now what happens is this X and X2 goes into this hidden layers and then into this output layers. Absolutely fine. Weight metrics and chain rules are available for this. We call this method as a backpropagation. If this number of hidden layers, there is only one here, if it increases to say 5,000, 10,000 to a million or a billion, then you will have more number of parameters to train, more number of weight matrices to train. This is the weight. Weight is 0.42. You'll have to train a billion. Then it no more becomes a small MLP. It becomes a larger DNN or and larger deep neural network. So we'll just go and run this for a while and just visualize this. We have 2 blocks of data. One is on the outside, one is in the inside. Our job is classification. We need to classify or segregate these type of data into their own decision boundary. The decision boundary will have to be found out. We can clearly see from our own visualizations or from our with our own eyes that if I draw a box here surrounding this blue segment, then only I can have a separate classification of this two independent data. I'll go on the top and see certain things. Dr. Thakur had talked about epochs. Epochs are the number of times they will be computed. Learning rate, how fast you are going to learn this. If you put it to 1, 0.3 or 0.1, you are learning very fast. The moment you learn very fast, you forget also very fast. So that thing is not suitable for modern business or academics. We generally think about a learning rate of 0.001, which essentially means in layman's term is I'm taking very small steps, baby steps to understand my data. If I take very small steps, what happens is I take a gradual increment of my data and I retain a lot in my memories. My ultimate goal is to minimize a loss. Here is a loss, and we talked about the training loss and we talked about the test loss, the training set and the test set. So we need to minimize this loss. So once we try to minimize this loss, we will get this decision boundary. So let us settle down with 0.001. Activation function will be ReLU. Forget about the rest. Sigmoid and ReLU are generally used. Regularization will not be used. And if I start this up, you will notice that the loss starts to decrease. Once it has gone to an appropriate number, which is closer to a 0, we will know that we have properly trained it. Now you know that we have a complete boundary and our test loss. You're not interested in this training loss. Training loss will be low. That is not a big thing, but test loss should be very, very close to 0. Right now it is at 0.006, and we can generally say that this is a good model because it has fit properly with a proper classification. I'll do the same with regression and just show you how these things work. If I go with regression, I can see that I need to have a decision boundary separating in between these two classes, this blue ones and the red ones. I need to have a straight line which basically divides this into two parts. So I can visually see that if I draw a straight line over here to here, then I will have to, then I can separate them. And since it is a regression model, I will not have two independent output nodes, but one is enough. If I go on with that again, you see that the test loss decreases, and right now we see some sort of a line. But do you see a straight line or do you see a curved line? Anybody from the participants, do you see a white straight line or do you see some sort of a white curved line?
Right, curve line.
Curved line, right? But we talked about logistic regression, we talked about linear regression, where we saw y is equal to mx plus c. That was particularly a straight line. Why is this then a curved line? Because it is no more a logistic regression. It is based on artificial neural networks, which is polynomial in nature, which is non-linear in nature, and it has found out a line which best fits these two independent classes into their own segments. In short, in gist, your data may not be properly separable by a single straight line. Had it been properly separable, had your data been linear, go with the statistical model. If your data is not properly separable, if it is non-linear in nature, ANN is the right way to go. So if in a cell's data, as Mr. Murli was saying, if it is linearly separable, do not go with ANNs and big stuff. Go with a normal linear your regression. But for such type of data where it is not properly separable, go with an ANN. Obviously, you cannot go with a simple MLP like this. For your data, it might be a huge one. Are we clear with this? Why not linear at certain places and why non-linear at others? Are we clear with this? Good.
Yes.
Now, once this myth and the paradigm is clear that where to use what, let us dive into completely a no code system, or I will not say a system, I'll talk about a workflow right now. It will not be of any coding, it will not be of anything, but it might be useful for you as a professional as to how to use AI in your daily professional life. And it will be quite interactive because your inputs, your data is required. I'm very weak in describing no code situations. You will have to help me out. Coding is my forte, no code is not. So I'll go first with the data itself. What I have gone with is I've been using this platform for a few days, few months actually. This Zoho, I was initially a bit aback. Why not use Google Sheets? Why not use Microsoft Office? But our own Desi system is providing better functionality than the rest, then why not? So I went with this Zoho.com Sheets. We are only talking about tools right now. In this particular sheet of Zoho, if I upload, let's say the last day's one, which was session 3 data, and it was telco, right? So I'll just drop in this telco data for the churn prediction here and upload this. And we are going with the top-down approach, which means we will start with the data itself, not the bottom up. We'll start with the data, do some analytics and stuff, and then go for the easy part. Hard part first, and then the easy part. Now, if I click on this telco churn your data, I am invited with this particular sheet. It looks like a normal sheet, which also baffled me. Why do I use this? Then it struck me there are other buttons here. And over here we have Zia, which is fine. If you click on this, immediately I am presented with all relevant insights. I have nothing to do. I just received this and I got all this relevant insights. Histogram of monthly charges, most frequent partner, and everything else. So this also baffled me. I mean, how come it is so easy to do? In fact, without any code and all, I got this. Will it suffice my interest? Will it suffice my cause? Mostly yes, but sometimes no. What if I want something extra? I want something better than this, something specific. For example, I need to have a correlation between gender and churn. I'll be going along with you. I just selected both and I got count of this with churn. Churn, this should be your gender, I guess. No, female, male should be the one. Count of churn, I don't want that. Pie charts. With pie charts, this is a count of churn. If I click on this and then on the churn, I'm immediately greeted with this. But where is my gender? It has to be a gender, right? Let's see. Most frequent journey, I need a chart of gender versus what? Churn. Am I missing something, or is it not able to provide me? Obviously, I'm missing a lot. I'm not acquainted with this, and obviously, I'm missing a lot. But can this be altered? I mean, chart of churn. Can this be altered? Altered means, what if I am not going to ask anything? I mean, I will ask for a specific things and it will answer this. To do that, these insights and all are very good. If I take all of this data, go for the insights. Everything is absolutely fine. I get a lot of insights. But is this data accurate? We talked about missing data. We talked about duplicates. We talked about outliers. We talked about inconsistencies. Graphs and alls are fine. What if I want to do that? I found out this. I learned from you guys. I mean, I took some time to get into this. You go to data validation, not in data validation, data cleaning, fix inconsistencies. It's easy. The moment you see customer ID, I am not interested in. I'm interested in gender. There are no inconsistencies. Senior citizen, none. Partner, none. Dependents, none. Tenure, no. Phone service, no. This might help. Yes. We see that in multiple lines, we have, instead of no and yes, there are many uh, rows which have no phone service. Shouldn't this be a simple no? Because we are going to categorize this into no and yes. So if it is to be simple no, this thing has already found out and it is suggesting replace with no. This no phone service should be replaced with no. What I will do is I'll just click on this and there will be no inconsistencies found. All of them will be done. Similarly, data cleaning missing values. If there are any missing values, it will figure out and it will show you. I'm not sure where there is any missing values or not. You'll have to go step by step. This is slowly and getting on our nerves. We have to do it manually. What we have to do for our time is important. Find duplicates. It has found no duplicate entries. Very good. All these things are okay. Let's say we have done our data cleaning from here and I want to have a EDA, but I love this feature. This feature was very good. I mean, instant uh, explanation or insights is pretty good. Let's say I now have all this data cleaned and all. What to do next? Now I will go not in the depths, but easier ways of doing things. This was okay. Zoho does a lot of things. I haven't gone through all of them. You might. I just said ki you can go and look into it. Now I'll go into the easier parts. I'll dive into something else called as this raw graphs. I'll be sharing all this. In raw graphs also, you can upload your data the same way. It is for EDA and all. You got your data. All these are been cleaned and all. Now you can select a chart. For example, I will go with a line chart, simpler. Once I go down, I can put gender here. But gender will not be in the line chart as it is a categorical column. I will have to have tenure, and then I can have something like tech support. Maybe no, that is monthly charges. That will do. Immediately, I should see there are type mismatch. What is type mismatch? Streaming TV contracts. This will also not do multiple lines. What was the other thing? Tenure is thing. Senior citizen. There was numbers. Monthly charges. Tenure and monthly charges. So if I go and take monthly charges, where is this monthly charges? Monthly charges. If I drop it here, I should see some sort of a graph. And you can customize this graph at your own will. I mean, do whatever you like. From these two all I have understood from these two tools is that from Zoho, You can actually clean your data, have your insights. It does a lot of things, which you will have to also explore from your own side. I haven't gone through it in depth. And this raw graphs. Tell me in one single word, which one would you prefer for data cleaning and EDA? Which one would you prefer?
Zoho.
Zoho is the one I should also prefer. So today's session will be an interactive one. So let's, if Zoho is much more preferred, then do I have a thing called as an insert graphs and all? That has to be also seen. Insert chart, as usual with all charts and all, you can have your own charts. Okay, we have cleaned our data with Zoho. We can see that we can have these things done. What if I have to do some MLOps, machine learning on this without using code? What I would suggest is this, which is this last one, ML console new dataset. If you go to mlconsole.com, here there is an option to load the data. Let's say we have that data, same data here. It immediately says these are your data. Select a target. Our target is churn. Very simply. Go over here. We do not need customer ID. We removed it. All others are required, and churn is our target. Now it simply says finish and train a model. There are two parts, classification and regression. I mean, it cannot go simpler than this. We immediately see it starts training. It has started training. It is showing as accuracy as it is percentage and all. Model loss is also decreasing. This is too easy to be used for any sort of business heads or academicians who do not want to do anything else other than to have a simple model for regression and all and do some predictions. And that's it. When do we stop? Currently, it is at 79.6 something. And it has stopped predicting. So we have a final at 79 point something. Next, we have this model and we have this launch. If I launch it here, I can see these are the parameters, contract documents, yes. If I take this and go for predict, it will predict the churn. Similarly, when you have a new data of a particular customer, let's say I have a device protection set to no, this will be, I guess, no, and I will change this total charges to something 10,000. Will this guy churn? Predict. Churn is simple, no. Total charges, if it is 1 million, will it predict? Still no. Why? Because our model hasn't trained beyond 79 point something percentage. We need to train it more. So we got to know about three tools, just simple tools. You want quick visualization of your data, go with Zoho. You want data cleaning, go with Zoho. Get the data cleaned. You want to have a simple model for training, go with this ML console. This is the simplest pipeline that I can think of with a no code. So take Zoho, clean your data, get basic EDA insights, and then use it in ML console for prediction. I'll be providing the links. Now what I'm going to show you is why not have a tool which does all of this without much headache. You have your own profession, you manage your own time. Why would you spend so much time on this? To go with this. This we have been using for a long time. It is provided by Google, called as notebook LM. Dr. Thakur had already, I guess, talked about this. Notebook lm.google.com. Obviously, there will be some problems regarding sharing your data to the cloud, but for non confidential ones, you can obviously share. Let's go with here. Now I will be very slow. Create new notebook. It immediately greets me with drop your files. I can drop many files, but I will drop just this, which is my CSV file, my Excel sheet, my data. And it's a 100 KB file, so it should not take much time. Yes, done. And immediately it starts to summarize this. The name is still untitled notebook. Change it to churn. Does it stop here? No. What we will do next is we'll go over here, search the web for new resources, churn statistics in telco, 2026. Now we are diving into the generative AI segment. We're talking about LLMs. And I click over here. What it will do is it will go to the internet. It will find out its own resources on the churn statistics of inner telco of in 2026. It has found all this. Let's go and click on import. Now we have a comprehensive source of all knowledge base on which our system can work on. For the time being, let us concentrate only on the churn CSV. I will switch this thing off. 1, 2, 3, 4, 5, 6. Every single thing is off. And in the bottom, if I write simply analyze the telco CSV file for churn, am I doing much? I am just doing this. Rest of my work is taken over by the LLM, which is Gemini itself. And believe me, it's free. It's completely free. So it provides you a primary drivers for your churn in this particular CSV only. Now I'm not satisfied with this. It's a report which it just found, but I'm not satisfied with this. Why? Because I need some data tables. So I will just simply write provide in data tables. Now it will be providing it me with data tables. Now my question to the participants is, what can be a basic fundamental question in this churn statistics data? You are no more limited to doing stuff using a spreadsheet, missing values and all. Now you have a properly set LLM to do that, Gen AI. What would be a proper question to ask? Can this be something like, what are the major contributors to churn? Am I right or am I wrong? All right. So let's write it down. What are the major contributors to churn? Remember to put it in caps, the first letter in caps, as that was the name of the column. I have nothing else to do. No manual labor, no nothing. I have checked it out. It does absolutely right. Because in the back end, it is writing its own Python code to analyze this. Whatever code that we showed was for your own knowledge base Now you are using somebody else's knowledge base to create this. Now these things you will require, you will see there are 1, 2, 3. These are all references to the exact data points from where it has found it out. This doesn't look good for me. What do? Let's say I'm a business head. I need to provide a report on this. What simply I will do is I will click on here, save to note. Once I click here, we see a note is being created here. I'll go over here and convert to source. Now I have a new source. I'll just delete all the rest of the source for time being. 1, 2, 3. Let me just delete them. Why can't I delete all of them? Okay. Okay. My new thing was key determinants. So I will uncheck only that. Where is my key determinants? Key determinants.
Second from the top.
Second from the top. Correct, correct. So now I have got 2. I have taken too many sources. Now I will just tick only this key determinants and nothing else. So henceforth, any knowledge base that I will be working on or questions that I will be asking for will be based only on this key determinants. Now, as a business head, I need to provide a report, a detailed one. What I will do is on the right hand side, I have a simple thing called as reports. I'll click here. Immediately it starts to analyze based on my source, which is only one right now. What sort of report do I need? Strategic retention roadmap. Let us go with this, but click on this, edit. Comprehensive strategic roadmap, yes. Now, beneath this, you can write your own preferences for your company alone, which is company requires in tabular format. Detailed but concise. Go and click on this. And it will take some time. Let me sip my coffee. Let us wait for this. And in the meantime, based on only this, if I want to show it in a slide, but I will not create a slide, I want to create an infographic, click on this infographic. Let it also run at the same time. If I want a slide deck, click on this. Let it also run. Let us wait for some moment. When it's done, we will come back to it. In the meantime, I'll just ask the participants, was this easier than the rest? Because this does your missing value duplications by itself. It is running Python code behind. Was it easier than the rest? Okay. And the best part of this is it is free. Second thing is almost limitless. We have been talking, hyping this Gen AI a lot, but we seldom use this for our own benefits. We only go to chat GPT and ask for something, get some answers, and we are done. But deep dive into streamlining things is the one which is actually the beneficiary part of Gen AI which we missed. One of them is done. Strategic retention roadmap. If I click on this, this goes as your report for your boss, or if you are the boss, then it's for you. and it's a very comprehensive report. We'll just glance over it to see if it actually makes any sense. It has already found out that contract type, 10-year window, which is my zone, monthly charges, all of them it has found out. Segment specific interventions where it is required, which is also important and required, correct? Service bundling and value augmentation framework, yes, that is all right. And we already know from the last session that fiber optic was the problem. Yes. Contractual and final friction reduction. Anybody from here who is from the business background in this, particularly in sales and retention, who can actually say if this report will do any good or not? Is it good enough? Anybody from a business background? Anyways, we have two other things, I guess, running in the background. Are they done? Yes, we asked for a infographics. Is the infographics done? This was the infographics created by this particular tool, which is Notebook LM. Use this wisely, use this judicially, because this is a good tool. Now, we have short-term commitments and every single thing drawn in a single way. The left-hand side, we have the high-risk churn profile. On the right-hand side, we have the high loyalty, which is low-risk churn profile. This was the infographics. Was the slide deck done? It is being done. In the meantime, we also talked about agentic systems. Dr. Thakur was talking about agentic systems. This is one of the agentic system example that I could show you right now. While this is running, let me go back to your most dreaded thing, which is VS Code, which is this. I'll show you an example of a code-based agentic system. This goes into the realm of money. You have to spend money to get this, which is Copilot. Ms. Iyer was talking about air pollution. Am I right? Ms. Iyer? I don't know if she's here or not. Now what I will do is...
It was about air pollution, sir. Yes, it was about air pollution.
It was about air pollution. So let us... We have a blank canvas here. I have got no data. I have nothing. And I want to do something with air pollution data. So I need to have some data. I'll show you a glimpse of what agentic coding can do, but you have to pay for this. It is a paid service. I will ask for simply go fetch me. It's like a dog. Go fetch me a CSV data on air pollution from GitHub. There's a place where you can find it. Analyze it. Create a full EDA with complete data pipeline with missing values, imputation, and I leave it there, etc. And I click on this. What it will do now is, you are looking right now at an agentic system, which is first is going to optimize this tool, and it has started working. It has already started working to find out the independent. And I'm not typing a single thing. It will
Abhijit,
go to the websites, it will find a data, it will do the imputation, and it is asking me whether or not I should go there or not. I said allow all commands. See, it encountered a problem which is not found. The problem will be solved by itself. I have got no intervention in this. Every time it finds a problem which is stated in red, it will find its own problem, it will solve it, get that data, and do its own job. I will not do a single thing. And it has already created a new file.
Abhijit sir, which platform is this which you are doing this right now?
I'm using VS Code as an IDE, and I'm using Codex as my tool.
Okay, sir.
If you are a paid user of GPT, that is Chat GPT, let's say a plus version, I would suggest that for any business professionals to have it in your institute. Then you will have this Codex as a supplementary as free, completely free.
If we opt out for ChatGPT subscription.
If you opt in for,
Okay.
if you opt in for that $20 to $23 ChatGPT subscription plus one a month, then you get this. Other subscriptions which are higher than this is also okay. In fact, the smaller ones, which is 200, 300 rupees a month, the GO subscription will also provide you this.
Okay, and
That is one way. And
same applies for that V code also, sir.
VS Code is already free. The ID is already free.
Okay.
ID is already free. All you have to do is
for Codex, I have to apply for the subscription or get that subscription so that I would be able to do all these things on
yes,
that.
that is one way. Another
Okay.
thing is instead of Codex, I will just write it down. Where was it? I will just write it down. For code-based systems, anybody who is into PhDs and stuff like that right now also could go this. Codex comes from ChatGPT subscription. That is one option of coding. Another is GitHub Copilot. This will be from GitHub Microsoft. I'll just write down the prices. I'll just this is around $23 including taxes, $23 per month, and this is $100 per year. You can choose any of them. It depends on your use case scenario. If you are in a business, organization, go with the ChatGPT one. If you are in a coding-based organization who codes a lot of things, go with the last one because it saves a lot. For others who are into sales and all, I would still suggest go with this. Any subscription will do fine. This ChatGPT subscription, we only go to ChatGPT and type things and get things done, which is this. This is just the tip of the iceberg, but the main focus is on the coding agentic part right now. So this does well. I can see that it has already done and it has finished up with all this. Miss Iyer was talking about PM 2.5. It has also kept that in mind. It has created 2 files. It has already run those files and it has created box plots. I haven't done a single thing. The heat map, the distribution plots, missing values, there are none. So everything is done by this guy. When does this type of agentic systems matter? When you need to have some rapid development done. But trust me, When you have a niche ERP system, niche business proposal to be done, it is always 80-20 rule. 80% of the code is to be written by the human, 20% is to be written by the AI. This has to be maintained, otherwise there will be problem, because do not leave everything to AI, there will be problems. But for small cases like this, it's absolutely fine. So that same data set can be analyzed using code also, without writing a single line of code. You can actually vibe code. It is known as vibe coding. Instead of typing a single line, you can ask to do it. I'll return back to my original one, which was this, I guess. Is this churn thing done? Yeah. Where is my slide deck? These are the slide decks, I guess, which it has created while we were doing some other jobs. Some AI system has created this slide deck. And it is based not on some random data, it is based exactly on the data that you have provided. Is it
That
well
is,
enough for your Hanji?
that is the Excel that we uploaded, right, sir?
Exactly. The data that you uploaded, that Excel file, it took into the it looked into the data, analyzed it, then created. I'll just go with the flow again once more. We uploaded our data sheet. We asked a few questions. Based on the questions, it answered something. We converted this answer into a knowledge base, which is this, transferred this knowledge base to source, and then we asked for something else. Should I repeat this again, this process?
Yes, sir.
Okay, so I'll go with a new one. This time we have used VS Code to download some other data, I guess, from pollution. So I'll use that. Instead of that, I mean, this business plan on. Now, where did I write that? Session 4. Yeah, got it. Air quality cleaned. If you can look into this, do you see two files? Air quality cleaned and air quality data. Somehow is it visible? Because I cannot zoom into this. Let me go with this air quality data. Should I go with the churn example or the air quality one? Which
Air
one?
quality one. Sir, we will go with air quality one.
Okay. Create new. What I will do is drop in this air quality data. Remember, it's not a clean one. So I just dropped in. I have only this file, which is 2 MB size. There is a small glitch in the system, which is if it takes too long for a 2 MB file to be uploaded, do not panic. So what you need to do is simply, it has gone too long, so 2 MB will be uploaded. Go and refresh this page. It is already done. It was not showing you, but it is already done.
So we are uploading this in which format, sir, over here?
It's a CSV format.
And to which platform we are doing it?
Notebook, LM,
Okay. LLM.
LM, notebook, LM.
Okay.
That is the only platform that you will be needing right now, and it's completely free. Completely free. So now that we have put up our data, first and foremost, let me change the name to air quality. Spelling क्या है air quality का? हाँ ठीक है. Now what I will be asking is, do I know what the data looks like? No. So what I will be asking is, show me the first 5 rows and tell me about the columns. Isn't it simple language? Because I haven't looked into the data, so I just want to see what the data is. As far as my knowledge goes, there is one more thing as a PM10 other than PM 2.5, and there is SOX, NOX. All these are also important. Okay, so we have these particular things in the data, and I'm not going into this. I'm just asking it. Year, month, day, hour, PM 2.5. What is dew point? I said this is dew point, temperature, pressure. I'm not sure what this is. This must be biologic wind direction. I think so. WD should be wind direction. LWS, no idea. What is LS? No idea. Now, when I say I have got no idea, has it provided me anything regarding this? Because I asked for the columns also. It said LS. Yes, it is a cumulated hours of snow, cumulated wind speed, and all this. In spite of me having no knowledge of the data, this has used its own knowledge, since it is an LLM, to provide me an insight. Now, what I will do is, what can be done with this data? I'm not sure. I'll ask, is this data suitable for regression or classification? I simply asked. I'm just acting like a blind child. But in academics, you should not be a blind child. You should know of your domain. For business, it's okay. For predicting, it says for predicting PM 2.5 concentration, you can use environmental features like temperature, dew point extra. Other than this, correct. So I'll do this. I'll take this. I'll just copy this. Let me know how to do this. AI is hand-holding me, but had I been very proficient in this particular domain, I would be hand-holding it. It is checking for my files, which is simply one file. Why is it taking so much time? Because it is writing a Python code in the backend and checking it. It is not doing something, hallucinating, which is the best part of it. It has provided me a step-by-step guide, data cleaning, pre-processing, feature selection, splitting the data, the things that we have been talking about, choosing a regression model, and every single thing. Now, I want to provide this as an academic, in an academic, not in a paper में तो नहीं जाएगा, but in a seminar or something where I want to show my methodology. What I will be doing is provide me a methodology of the regression in details. Now I will be going into the other things. I'm going into the depth of it because in the business model, it was straightforward data. Here, I need to have some other things to be done. Methodology, results and all. Results you'll have to do. See, now it has written me a proper methodology. This is the only thing that we are concentrating right now. So this part, what I will be doing is simply save to note. You will immediately see on the right hand side, we have something like this. And then we can go to more. We can export to docs and stuff like that, but we are doing this. Convert to source. It is converting this into my knowledge base. Now for creation of the infographics and all, I don't need actually this, but I can leave it there also. What I will be doing is, say for the infographics, I click here and I write over here the methodology in details, and that's it. And for the slide deck, simply click on slide deck. Let it run. I'll have a sip of coffee and wait. Up to this, is it clear?
Yes, sir. Clear.
For academics and your presentations, I guess it's the only tool that you can go with. But my advice would be to dive into, it might sound or look hard, but you should code. Coding gives you not just freedom but pleasure. This uh, removes the time that you spend doing mundane job, this AI and stuff. Absolutely fine. Makes sense. A lot of sense for business people, where they have to provide instant presentations and all. But for academics, put some time into the data. But initial orientation, initial EDAs can absolutely be done by this. It will take some time because I have taken this data set also as a source. I shouldn't have taken that. It would have been easier.
Sir, I have a query. Like,
Yes.
if we are using LLM or Zoho for our data set, will it be plagiarized if I'm using for writing a manuscript?
What is plagiarism? Plagiarism is something which you copy from someone else. When you have a data set of your own, data is numbers. There
Yes.
can be no plagiarism in that. Other than, I mean, when you take data from somebody else's paper without acknowledging, that is plagiarism. Other than that, dealing with the data has got nothing to do with plagiarism. Now,
Okay.
coming to all these writings, these are uh, generative AI generated. This will have zero plagiarism or copied from somebody else. What it will have is, it might have a, you know scent of a fragrance of AI. There are certain words which AI uses in the domain of state of the art. For example, it might add in the landscape of. These words are telltale signs of AI written document. I'll tell you how to evade that. We are all Indians. We have our own accents. We have our own way of talking, way of writing. Why not let that be known to this particular person, which is this Gemini AI? I'll just simply write. I'll not go into the stylometry part, but I'll just simply write, I am a non-native English speaking, spelling जो भी हो, speaking individual from Chennai. Assume my role and my stylometry. Evade AI traces in your responses. It's a trick which immediately makes sure it will humanize this particular notes, and you have you will have zero plagiarized and almost zero AI content in your methods. If you go to chat GPT and ask something, it will write something out which a single glance can say that it's an AI written one. But provide your own identity, your individual identity, and it will assume the role. Let's go with this. Initially it wrote, to predict PM 2.5 concentration using regression, you should follow the detailed methodology. Then data cleaning, data handling missing values, and we have this. Uske baad tha. If I go down after writing this, how is it written? First thing you must do to data cleaning, do the data cleaning, because many use both are different, isn't it? Isn't the second version more colloquial, more like how we talk? Ayana. So make sure you let this AI thingy know who you are. If it knows who you are and it assumes your role, then the plagiarism is not there, but AI part, that's fragrance of AI, will be also gone. Absolutely not advisable for business people. For business, the tone is set the tone first. Set the tone to formal, precise, and corporate. This should be the one which is for business. There are a long string of prompts. Prompt engineering is a big part. There is a long string of prompts. If you wish, I can send you those prompts, which will actually make your you know reports more professional. This is again back to the professional one. Had this been written as set the tone to formal, comma, academic, precise, and jargonic, it, it would have taken the role of somebody who writes in a non-native English speaking, but for a public patient. So whenever you are in chat GPT or wherever you are, set the tone. The tone is important. Let it know who you are. Am I clear with this?
Sir, you said you'll be sharing the data, the file and all. Where should we access?
No idea. I have just sent it. To send it back to you is somebody else's prerogative. I'm not sure how they are doing it.
Right, sir.
Any other questions while we wait for the slide deck, because the slide is taking too long. Yeah, slide deck is taking too long because I've taken two independent ones. Any
I
other?
think you can refresh once. It will be ready.
I refresh just now.
It is.
I
I
have
think
taken
it
this
is
entire data, right? Now
Abhijit
it is
sir,
going through it.
many times. It is a glitch, as you have already mentioned.
Yeah.
Abhijit sir,
Hanji.
uh, in that word file, somewhat you have written that Zoho and everything there. I have gone through that. There was some Prism AI somewhat.
Oh, are
Uh,
you from an academic background or from
no, not from
you're from
academic.
business background, right?
Yes, I am from business. Means I am from a designing engineering background.
Engineering background. Do you have to do anything with writing equations?
No, sir.
Okay. See, Prism. Prism. Let me have some coffee. Gaur, Dr. Thakur,
Yes.
can you talk about this Prism for 5 minutes? I'll just have some
Yeah, sure. I have
coffee.
already mentioning yesterday regarding the Prism. Prism is basically for actually document writing. You can think about something kind of a latex editor. If you have already explored like overleaf, I was mentioning. So if you have to prepare any kind of document, okay, with well formatted document with equations, tables, not much focusing on what will be the format, how to write the equations or something like that. This Prism is a tool from OpenAI which will be giving you all the required functionalities as well as the LLM power. Okay, so you can explore, research, search, and at the same time you can write documents as well. So this is the place where you can prepare document right from scratch. If you have suppose some complex equation which you have written in your pen and paper, you can just upload the image of the same and you will convert that to a equation. directly. It can also search the internet for specific data, collect it, and put it as a table as well. So it's a like you can consider guided, assisted latex document writer with smart assistance from LLM, GPT 5.2. So this is actually the general description about what the Prism is from OpenAI. If you have some any specific question, are you exploring this tool?
No, sir, I was just going through it.
Okay, so this is a very new tool that is released in, I think, in January 2026 by OpenAI. And Overleaf, if you are familiar with Overleaf, then you can actually get the strength and difference between this. As Abhijit, Dr. Banerjee was showing, suppose this was a kind of a document report he has generated from LLM. Oh, sorry, LM notebook LM. Okay, so you
For
can write.
example, yeah, if I take this one, this is in Word, right? For the last report, what I will do is I'll just, how does it look? It looks okay for a report, but if I just copy this thing up, go back here, paste it in the bottom, and I
Write that colorful professional. You just
yeah,
mention other things.
need a report, need a professional report based on the prior means on the top one, based on the prior, colored, marked, tabular, fixed to page width, and with tick Z. Now, what happens is your GPT 5.2 will take over. It will read this document. It will create this document. You are looking into this. This looks so okay in Word, but for academic and for professional reports, for type setting, we generally require something called as a LaTeX format. On the left hand side, you are looking at the code. On the right hand side is a actual rendering. Now it will be writing it this entire code, and it will be rendered on the right. Let us wait for it. It takes time. Still as Prism.
So to use overleaf,
Accept it. Accept. It is already done. Tick the tick.
Accept. Yeah, accept.
Yes.
so for using overleaf, that is free. If we are subscribing to ChatGPT 5.2, overleaf we can use freely or we have to pay for
This
it.
is an alternative for overleaf. You will not be using overleaf. You can use this Prism.
Okay, sir.
Instead of overleaf, you can use this Prism, and it works brilliantly. Currently, there are too many tools online which are available mostly for free, but it is advisable to go with a plus subscription of ChatGPT or any
Yes, sir.
Gemini will also do, but do have some if you are into any sort of profession. If you are an organization, get a business plan that makes the finance less costly.
Okay, sir. No, sir, I have subscribed to ChatGPT only. So
Use it properly, because
yes,
we are not using this chat thing properly. Say for example, I am in ChatGPT. If I ask it with the same air quality data, the same
yes,
thing can be done here also.
yes,
Correct.
sir. Yes, I have done, sir, once.
I just need to write need EDA, and simply this. It will write its own code and do something. What
Yes,
I
sir.
did not do is writing its own code. What I did not do is I did not select this. I should have selected thinking mode.
Okay, sir.
And these things also have something called as memories. In your settings, in your personalization, you will see base and style. Here it is set to professional. You can set to anything, but you should set it first. professional or something else. Bottom there is the custom instructions. I said you need to let it know who you are, right? So that thing is set over
Yep.
here. What
Yes,
tone
sir.
you require in custom instructions. So all
Yes.
of this will be taken up. These are the chat
Okay,
thinking.
Dr.
Yes.
Banerjee,
Yeah.
as we take the questions, I think we are already, time is over. So
Mhm.
maybe the participants and the organizers are waiting.
Yeah.
So once this is done, okay, this is the slide deck is ready properly.
And it is based on the data set that has been provided. It's not something from Mars. Same goes with the business propositions. You will notice there is a written over here notebook LLM. There is a watermark here. You know what to do. You can put up a simple blank, your name's tag there in your slide deck.
And check once whether the latex is ready or not.
LaTeX will take time. Yes, there were too many errors. It is checking. There were too many errors. It's still errors. It should have been done easily. I don't know.
Probably you could have deleted the previous already existing code,
Yeah.
then paste it, then it will okay.
Otherwise, I will just go over here and say fix it. And make sure if you are in a pro subscription, go with the thinking mode. Let it think for a while. And garbage in, garbage out. Your prompt is more important than anything else. It has to be a long prompt. It has to be very detailed prompt. Otherwise, do that won't suffice. These LLMs are very, very, uh, have a very good potential, but we are not using it properly. So this thing is the corrected one, which it has provided. Prism has a slight problem right now, I guess. Yeah,
They're
just stop.
updating. So,
There's updating and all. So I'll just copy this, go back to Prism. It still has what is Prism. In the bottom we have this. It had the first part, and this is this. Now you can easily see, I guess, from here, which is this. Which one looks more professional? This on the left or the one on the right? Isn't this more professional? The one on the right.
On the right, yes, sir.
See, the thing is, LaTeX will provide you a very good professional report, data reports, publications, sales report, which is fit for printing, actual printing on a paper. Whereas Word provides you something which is not so suitable. Word is rasterized, whereas LaTeX is vector. Every single letter that is drawn is actually an equation. And the most important part is you go on zooming here, it won't, make a fumble here. The more you zoom, there will be no distortion. Whereas on the right hand side, if I zoom in very closely, you will see that for all the images and all, there will be some sort of a distortion. Very good with equations, numbers, makes more sense with numbers and all.
Thank you, sir.
Citation, references, all.
References and all. Our suggestion would be to go with latex if you are into academics. If you are into business, you can stick to Word, or you can use the latex if you want more professional one. Are we
Okay,
clear
I
with
think,
this?
Dr. Banerjee, I think we should stop now.
Yeah. Okay.
Already it's 5:46. So
Okay, I'll
thank you
close
very
this.
much, all the participants. Thanks for
Thank you,
both,
sir.
from
Thank
both of us for your participation and your involvement. So now I would like to hand over the session to the organizer team. Professor Dr, are you there?
Thank you, sir. Yes, sir. Yes, sir. Very much. Yeah. Thank you very much, especially our respected resource persons, Dr. Abhijit sir and Dr. S.G. Mitra sir, for wonderfully conducting the sessions. It's a very hectic 2.5 hours, on the weekend, totally 5 hours, Saturday and Sunday. But thanks all the participants for your patience and your interest, especially to learn the AI, the nuances. And the session was extremely well and mind blowing. Mitra sir and MTC Global and IIIE, we have planned for advanced certification course in a series, because first we had the basic, now the intermediate, the next one is the advanced one. So we'll discuss with both the resource person, then we'll take a call on the syllabus, and I request all the participants to be there as a part of the WhatsApp group, and we'll come back to you soon on this the advanced certification programs. And I'm sure that it would be useful for to all of you, and we'll issue the certificate, the e-certificate, maybe in 1 week's time, as per the standard procedure. And we'll send it. Please check your inbox and spam, and I'll keep you posted on that certification program. Thank you once again, Mitra sir and Banerjee sir, for your time and sharing your expertise and wisdom. And thanks all the learned participants being here for 10 hours on both the weekends. Thank you once again,
Thank you, sir.
and we shall call off. Jai
Thank
Hind.
you.
Thank you.
Thank you, sir.
Thank you so much, Abhijit sir. Thank you so much for
Thank you. Thank you.
Thank you all. Thank you all. Bye bye.
Bye. Bye, all of you.
Going out.
Thank you.
Thank you, sir.